Welcome back. In this video, we are going to solve problem 1-83 that is taken from chapter number 1, Stress, and the book name is Mechanics of Material by R.C. Hibbeler. So statement is the 60 millimeter by 60 millimeter oak post is supported on the pine block if the allowable bearing stress for these materials are 43 megapascal for oak and allowable bearing stress for pine is 25 megapascal. Determine the greatest load P that can be supported. If a rigid bearing plate is used between these materials, determine its required area so that a maximum load P can be supported. What is that load? So you can see this is oak post and that is supported by pine block, clear, and there is a P load applied on it. So you have to, the allowable bearing stresses of both woods are given. So you have to find the largest load P that can be applied. And in B part, if there is a rigid bearing plate between these two, so you have to find the required area of this bearing plate for the maximum P load. So let's start with the solution. Now what we will do is that we will find this P for allowable bearing stress of this pine of pine wood or pine block. We will find P. How we'll find P? So we know that stress is generally equal to force per unit area or load per unit area. So for this pine block, we are given this allowable stress for this pine is 25 megapascal. So 25 into 10 to the power 6 pascal. So this pine allowable bearing stress will be equal to load divided by bearing area, clear. So load is not available, and you can see that it is mentioned that this is 60 by 60 millimeter. So this is 60 and this width is also 60. So this will be the bearing area, clear. So I will write this is 60 by 60. So I will in meter it will be 0.06 multiplied by 0.06, and allowable bearing stress is 25 megapascal. So 25 into 10 to the power 6 is equal to P divided by 0.06 multiplied by 0.06. So from here you will get this P will be equal to 25 into 10 to the power 6 multiplied by 0.06 into 0.06. So when you multiply this, you will get 90 into 10 to the power 3 Newton, and in kilonewton it will be 90 kilonewton. So you will get this P. Now this P is calculated, that is based on allowable bearing stress of pine. Now what we will do is that we will find this P for allowable bearing stress of oak, and we will find P. So allowable bearing stress of oak is equal to load per unit bearing area. So load is not known and bearing area of this will be same as 0.06 multiplied by 0.06, and allowable bearing stress of oak is 43 megapascal. So I will write 43 into 10 to the power 6 will be equal to P divided by 0.06 multiplied by 0.06. So from here this P will be equal to 43 into 10 to the power 6 multiplied by 0.06 multiplied by 0.06. And when you calculate it, it will be equal to 154.8 into 10 to the power 3 Newton, or in kilonewton this P will be equal to 154.8 kilonewton, and you can round it off. So P will be equal to 155 kilonewton. Now you can see you have two loads. This is load based on pine allowable bearing stress of pine, and this is the load based on allowable bearing stress of oak. And in question we have been asked to determine the greatest load P. So what? So our answer will be, answer of first part will be the greatest load P will be equal to 155 kilo Newton. So this is answer of our first part. Now we will move towards second part, and in second part it has been asked to find the bearing a required area of bearing plate so that maximum load P can be applied. So if a bearing plate is incorporated in between these two wooden pieces, so what will be its bearing area? So what we will do is that you can take for this maximum load P, because it is given as maximum load P. So we know that stress is equal to load or force per unit area. So we will calculate this area of plate based on strength of pine. Why we are taking the strength of pine block? Because it is the smallest layer, so we will design on the smallest one, smallest strength. So you can see this is the smallest and this is largest, so we will choose this value. So the stress is 25 clear into 10 raised to power 6 Pascal. Sorry, it will be Pascal. 25 into 10 raised to power 6 is equal to P is the largest load, so 155 into 10 raised to power 3 divided by the area. So from here you will get this area will be equal to 6.19 into 10 raised to power minus 3, and unit will be square meter. So this is the answer of our second part. And that was all about this problem 1-83. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching and supporting me.